Alright, hello everybody. So this is a quick review of the KGroundControl, the little app that I created for my own research purposes. So if you go to the repository, it should have pretty much all the needed instructions, which will keep being updated for future releases, because this is something I'm planning on supporting for quite a long time. Again, for my own purposes most of the time. But alright, so basically what this is a small communication piece of software that I developed as a supplement for the QGroundControl, because some of the features that I'm going to talk about were not available, at least not in the format that I needed them, and I wasn't able to find any proper software that does all of the things that I want. And also I needed to combine my prior research into just one application with a nice UI. So this is also my first learning experience of the Qt framework, which basically allowed me to do the user interface, which is also very convenient. But all right, let's proceed to essentially how do you use this. So if you are on the GitHub repository, what you should probably do is head to the releases. So it's going to be your best bet for getting the correct version of the software. Then just check the version that you want to use. Right now there's only one, of course. Then there are several, so these instructions are also written on the repository too, but this is fairly standard. You have standalone executables and installers. For some platforms, I'm able to do that. For others, you would just have to compile from source. So for example, right now I'm on Windows 11 to be specific, with the x64 architecture processors. So I can use either the Windows 64 executable installer or the executable directly. So there are two versions that I'm currently exploring, is using a installer that basically packages the dynamically compiled application, and a standalone single executable file that is done through a statically compiled Qt. It's a pain, but it seems to work nicer or a little bit more convenient. So right now let's just step through this version right now that I'm probably going to support more in the future, rather than using the third-party tool to generate the installers. All right, so while that is downloading, again, these instructions should be, whoops, that's wrong, all outlined over here on the page. I also give some instructions for the compilation if you want to really do that from source. For example, for platforms that are not supported right now that I'm still trying to figure out. One of them is pretty much anything running on ARM processor. Specifically right now I have a project that I'm working on, and I need to get this working on the Raspberry Pi. It actually works fine. It's just like I'm trying to generate a standalone either executable or installer, but I haven't done it yet. We'll see how that goes. It's just quite a bit of a pain to do. But everything else, Windows, Ubuntu, Arch, for the 64-bit platforms are available. That works just fine, and that's probably 90% of what you need anyway. But except for that, the application itself is the exact same. It's cross-platform, no changes to it whatsoever. For generating the installer, for now I've been using CQT deployer tool, so you can read on that how to use it and how to integrate it. I'm not going to cover that. Alright, so we have downloaded. So this is quite a big executable because this is all in one. It's basically like a portable version. 50 megabytes, good or bad, depends on your purposes. Double click on that should just run. It may ask you obviously for permissions, because this is going to access low-level stuff in the computer. We are going to need access to hardware. Alright, so for now, this is how the interface looks like. This is the version 1, the very first release. You have several tabs that you can interact with. Settings, shouldn't probably touch it. It currently just... So all of this is basically a manager or sort of a quick tool to work with Mavlink and forward data back and forth. It doesn't have a whole bunch of features like QGroundControl does, or any other app, really. It's more of a supplement providing things that are not actually provided by the QGroundControl. So the very most, I guess the very first and most basic one is that there is this communication panel where you are setting up all of your connections. They are done a little bit more explicitly. I like this way rather than automatic, which is how it is in the QGroundControl. You would have to click on add. If you have, it currently supports serial or UDP. Serial, obviously you would have to have something connected, then you can set your settings. UDP, we're just going to do this right now. You can say, for example, I just want to use and test it with the QGC right now. This is just a name. Convenience for your own purposes makes absolutely no difference. Then all the settings. For now, the default is actually set to the QGroundControl, just again for now. This on the bottom, if you are familiar with multi-threading, this is basically your update rate, refresh rate, or whatever you call it. This is converted into a delay in its own separate thread, and essentially sets how frequent you're pulling data and actually parsing it. So if you see that this is a little bit too demanding for you, you can try decreasing it. Or if you need something that requires a very demanding, high bandwidth, very frequent communication, maybe you need to increase this. So I wanted to expose this as a parameter, just because I think this is important for people who are developing things that are not yet certain what rate is good for them. And then there's some stuff in terms of like priority. For now, I'm just using the criticals, the most strict priority. If it is supported by the platform, this is going to be the most appropriate one for all of the low-level stuff that is related to communication. All right, so then we just confirm. You can get your details or whatever you want. Right now, it's more of a text format. But basically, once you've done that, you have this communication panel with all of your connections listed and the details. Once you click on one, and it's going to show you all of the details. All right, so just real quick, we can test this, for example, with QGroundControl. If we go to Analyze Tools, Mavlink Inspector, nothing is happening right now because we only opened up connection. We haven't really started talking. Again, this is all using Mavlink under the hood. Part of it is you need to be sending heartbeat for the people, or the programs and other pieces, to be aware that you are there. So there's a separate button for that. I can enable heartbeat. You see immediately we show up on the QGroundControl. It's aware, it knows all of the details about your platform, and this is something that is just going to be sent at 1 Hertz because this is what it's supposed to be. For some applications, this is actually not mandatory for my purposes, so that's why this is optional. Again, you probably know what you're doing if you're digging into these things. All right, so this is working. Basically now what we're trying to do is go through the other tabs. This is sort of a Mavlink inspector similar to this guy, just a little bit obviously different UI. Haven't really done a lot of in-depth stuff, but it does the basic things. Like you open it up, it lists you the packets that are being received. So right now, QGroundControl, let's actually do this differently now. So we close this, we no longer send anything, C0. We have to close the QGroundControl. And this is something, again, you learn on your way when you use QGroundControl a lot. It's not going to start talking to anybody until it hears the heartbeat. So we did open connection, but we're not sending heartbeat. This is a new instance of QGroundControl. Let me just close this. On the Mavlink inspector side, nothing is received. This is an important part. If we start talking, we receive heartbeat and it sends back a heartbeat. So this is basically how it works. But this is the heartbeat that is received from the system ID 255, which is the default for QGroundControl, and the component ID for that is Mission Planner. So I'm exposing those to be a little bit more specific. I know technically these are also written here, but again, this is more of a just looking at the raw data. I'm trying to get some stuff of this exposed to support multi-vehicle configurations and remote control. All right, so for now, the only things that we can do here, except for just browsing the data, is this screen on the right. And by the way, this clear would remove the clear tab, would clear the buffer, all of the data. Just in case you encounter any issue, you would just restart communication. It's not, nothing here is going to show up until you receive at least one packet from someone. So this is bluntly obvious. If nobody was communicating, this is just going to remain blank. All right, so on the right, this is something important for the project that I'm on right now. You obviously list out, this is listing out the status, armed or disarmed. QGroundControl is armed by default. That's just how it's done. If you talk with the PixHawk, that's probably going to be disarmed over here. The important part that it allows right now, which should be fairly convenient, is we can send a arming command. Here you go. This is the arming command. And a disarming command. As you see, these numbers change. The command message is the same, but of course we're changing what actually we're telling it to do. So this works. We can also configure to an extra flags that are usually not exposed, but I think they're important, is to force, and this is specifically for, again, PX4 firmware. So anybody else on the other side that doesn't adhere to the PX4 standards and parameters and commands may react totally differently to these and may have different commands. So this is, again, this is for PX4. But yeah, anyway, so these are force, like additional flags that should be exposed and are exposed. This interesting bind button is basically my first attempt into implementing some simple way of binding a key to it. So it opens this prompt. You can press, for example, enter, return on your keyboard, hit OK. All right, so now this is binded. So if I go back here again, we are only receiving heartbeat. If I am on this screen and I hit enter, I'm sending a command every single time. As you can see, this count changes. Whoops, that's heartbeat. Yeah, so command long 14 times, and 1, 2, 3, and so on. So it sends multiple just because probably it registers a couple of clicks, but basically this is now binded to the enter key. We can clear it and release the bind key. Now if I press on it, nothing is going to be sent. Same thing for arm and disarm. Right now, this is how it works. The limitation right now is that this is not a global hotkey. So if I am binded, so right now you see I'm pressing on the enter, nothing is happening, nothing is received, or I guess better this way. All right, so nothing is happening. Or if I'm even holding this window, right now this is an active window, and I'm pressing on the enter, nothing is happening. This is a limitation that I'm fixing, or I will fix at some point later, but you have to have this window active. Only when this window is active, it registers key presses. So these bind keys, they are only active when this Mavlink inspector is the primary window. Once you close it, of course, all of the settings and everything else there is gone. So whatever you do is not going to be affected by those settings. This is more of a quick interaction, not really a permanent thing. But yeah, I mean, it will continue to grow as I need more features, and I will keep on updating it. But the next step is something I desperately needed for my own research. This is motion capture tab that supports OptiTrack motion capture system, which does all of the, it's everything through UDP. It's receiving the data, so you can set up your connection. I don't have motion capture plugged in just now. We can simply obviously connect because this is multicast. It's not going to freak out about not seeing anything, so this is going to work. We're just not going to receive any data, but basically it has data inspector similarly to the Mavlink inspector, which shows all of the frame IDs that you received, and they are their data, meaning their pose, they're sent from the motion capture system. For display purposes, you can set up different refresh rate of this screen. It's not going to affect anything else except for, again, this screen over here. You can configure data bridge, which is basically, hey, yes, I'm receiving all of the data, but now I want to forward my motion capture data to my vehicle so it can be used. So this is an important screen. You basically establish communication, for example, in this case, QGC. You have also established communication. You received data from the vehicle, from the motion capture data. So frame ID shows up in here. You can select that. And then you can select the system ID and component ID that you want to be sent in your Mavlink message. Basically, the logic here is the other end, whatever it is, QGroundControl, or your vehicle, is going to look at the system ID and component ID, and if it matches its own component ID and system ID, it's going to use that data. Otherwise, usually it should ignore that. Additionally, I currently added support for 2 different messages that can be used for sending motion capture data. Some modules want, or some software packages want Mavlink odometry. PX4 actually prefers Mavlink vision position estimates, so this is the one that is selected by default for now. Yes, then this is the physical port that you configured here to write if you have multiple. For example, you have multiple serial connections or serial or UDP connections to your vehicle, but this is where you configure where you want the data be physically written to in case you only want it to be sent through one of your pieces of hardware for communication. You set up your rate and priority. Keep in mind, motion capture system is, well, something that is very demanding and has to be happening very fast in terms of data is coming in quite fast. It has to be parsed and be sent at a very consistent and fast rate. For the PX4, I've been using about, I think the docs say you need to have 40 hertz exact, or between 30 and 50 hertz, something like that. I usually send it at 40. The problem here is that the operating system that you use has its own limitations. For example, Windows will not support, or I guess it truncates your timing clocks or whatever. So all of your threading, internal threading and timing is only good within like 15 milliseconds. So anything faster or more precise than that, you're not gonna get consistent update rate. Basically, I had to run the KGroundControl in WSL, which is basically running Ubuntu Linux, to get consistent streaming rates. This is not a problem with the application. This is literally the limitation of the operating system. Alright, so this is pretty much covered. The other thing that is left is, this is it. Yes, okay. For now, there's no joystick. That will be part of the future releases. Don't forget also, settings are automatically saved. So you opened some connections. You close KGroundControl. You open it again. It is still here. So settings are automatically saved. This works just fine as long as this connection can be established when the application is ran, like opened or started. If it cannot, it will give you an error, well, I cannot connect to there, and it will delete that setting. May be worth making that as a separate parameter later in the settings. But for now, you can lose your saved configurations for communication if you don't have, for example, your telemetry module plugged in and that serial device does not exist. It will not be able to connect it on boot and boot of this application. It will delete that config, which again shouldn't be a problem. This should be fairly straightforward to configure. So, all right, the final, I guess, feature that I completely forgot about it is relaying your data. So, for example, you open multiple connections. Let's say, I don't know, 1, 5, 6, port 1, let it just be port 1. So you open multiple connections. For example, you have QGC and your physical port or whatever that you're getting data from, and then perhaps, I don't know, something else. Right, so 3 ports. Usually the problem that I ran into, you have one telemetry module, but you need multiple applications to be talking with the vehicle through that single port. There are multiple ways to do it, I guess, but the one that I chose is like I want one app to do this bridging, data forwarding, and basically talking from single port, which is, for example, is a single serial port, and bridging that data into multiple and receiving data back. That was a very important limitation that is part of the QGC. For example, in QGC you can configure data forwarding, like telemetry forwarding, to some UDP port on the local host, but it will not read that data back and send it, to the vehicle. So you cannot have two-way communication, which is very unfortunate. So this had to be implemented separately. But basically, to do this, you also can see all of the settings here. You see right now relay targets none on all of these. This is the default. You go to, for example, your port 1 is, I don't know, your Pixhawk or something like that. You click on the relay, which basically says whatever data comes into or out of the port 1, I want that to be relayed without any checks automatically to these 2 ports. These can be UDP or serial, doesn't matter. Alright, so this data now, if you go back to port 1, you see relay targets, QGC, and port 2. So whatever comes out of port 1 will be automatically available and sent through port 2 and QGC. You can also do something like you can do this for each and every port. For example, I want port 2 to also, like whatever comes out of the port 2 to be also relayed to QGC. I want QGC to see everything, for example. Alright, so now just picture it in your head. All of the data coming out of port 1 gets bridged to QGC and port 2. Everything coming out of the port 2, except again, so this is just one way. So when you are sending this data, you're sending it sort of into these ports. They are not subject to relaying afterwards, so you're not going to have, like we just configured port 2, right? So this data coming out of port 1 will be sent to connection configured as port 2, but it will not be relayed again to QGC. This relay setting is only for data coming out or from, I guess, this port 2 right now. So data, whatever new data is coming from the port 2 will be relayed to QGC. QGC itself, whatever data is coming out of this or being read from this port, it's not getting forwarded anywhere else. So I hope that makes sense. I guess I'm going to walk through a different example in a different repository showing an exact configuration for the RRTV and other application that I worked on. So this should become more clear. But of course you can remove all of these